quite a few at 3 o'clock. Okay, just so you're aware, I'm going to record the session for the benefit of students who are unable to attend otherwise. This is a set of exam questions, and it's the new spec style of exam style questions for Chapter 2, Probability. And what we've done is we've put together all these sample material papers. That's a two-way table which they're asking to turn into a Venn diagram. Here we've got some data with overlaps. We'll have to be careful there, yeah. Venn diagram, two-way table. Let me get this Venn diagram again. I like in two-way tables becoming Venn diagrams, aren't they? Was that an actual 2018 AS? So that was an actual genuine paper. What about 2019 L? Let's have a look. There it is. Two-way table. Statistical independence. Oh, now we're talking. Lovely. All right then. So I probably want to do that statistical independence question. Let's get going with some of this stuff here. Venn diagram, what we're going to represent, FEB. FEB, they're the actual categories that are displayed, FEB. For the benefits of those at home, I'm hoping you've got your copy I gave you today. So you're still able to see this two-way table. As we're going to have a go at drawing the Venn diagram for the three categories FEB. Where E is 18-year-olds, E dash would be 17-year-olds. B would be brown hair, so B dash not brown hair. Let's have a go. Just like the Venn diagram, start with the centre and work outwards. By centre, we're looking at F and E and B. So you've got your two tables, your top half is for your females, your bottom half is for not. First column is those with brown hair, and the top of those two is the 18-year-olds. So the first value there would be 4. There are 4 female with 18-year-old brown hair. Now, if we do F and E, besides the 4, you're looking for the other 5 to make a total of 9 females who are 18 years old. Next overlap, F and B. So we're looking at the other 2, which happen to have brown hair. And then 18-year-olds with brown hair, but not females. So we'll look at the bottom table there. Brown hair, 18-year-olds, but not female. There we go. Now, what else have we got? How about just F, but not E, not B? So not brown and 17. So the remaining 2 make up the female circle there. 18-year-olds, not already considered. So not brown hair, not female, but still 18. And then those with brown hair, we've had the 4, the 2, the 4, it's just the 1. which not 18, not female. The remaining number that's missing is that 0. Now that 0 is not F, not B, and not 18. So that 0 doesn't go anywhere else, which is quite convenient, and hopefully that totals 22. And hopefully you can check your mark scheme. 254, 244, 10. Yeah, agreed. Right, try and fold over that mark scheme so you're not taking a peek. F and E, F and E. So in this situation, you're looking for that overlap between F and E. So 9 out of a possible grand total 22. The fun begins with the conditional probability in part 2. What's the probability of having brown hair given F and E? So instead of out of 22, you're actually out of these 9 students. There are 2 components. You've got the 5, which are just F and E, not B. And you've got the 4, which satisfy all 4 criteria. And that's what we're looking for, because we want the brown hairs out of those 9. So given F and E, change that denominator to 9. And given brown hair, so we want brown hair out of those, so 4. You can convert those to decimals, they're completely acceptable. So 0.409, 0.444444. What does B line F and E actually represent? Well, it's the probability, because the P notation is there. Probability of a student, of a female student, because it's F and E. So female and 18. What's the chance of them? Has brown hair. Or you could write, find the probability that a student has brown hair given that the female and 18-year-old. Probability, I've worded it the second part, probability of a random selected 18-year-old female student has brown hair. But if you want to go straight to how it looks, probability of brown hair, probability that a student has brown hair, given that we know the student is female and 18. Okay. So that was the specification AS paper from 3 and a bit years ago. Be careful with the question here, just like I explained last Thursday. The only thing that's different here is they haven't given you the grand total. They've had to tell us the none. You can tell who's written this because I'm a bit of a joke. NAF, NAF. Politicians are NAF. NAF is like an old common swear word. You know, like pre-crap, pre-show. Politicians are NAF. I wonder if NAF actually stood for anything, but the way I'm interpreting it is, you know, NAF. Instead of a grand total to work for, they told us that one person said, no, I don't like any of those. 8 like all 3, So if we look at the NA, we need 37 to make the grand total of 45. Those 8 who like all 3 are already considered in those overlaps. A and F require 4 to make 12, and then 6 at NF to make 40. N grand total 60, 14 on top of the 37, I think that's 51. So another 9 for 60. 49 for A, so another 6. 12, 18, 18 is another 3. So try and fold over. Yeah, they've drawn it slightly differently. They've put N at the top and then A to the right. I tend to like to draw the first 2 circles at the top. I suppose if you put your mark scheme on the side, it looks about right, doesn't it? 9, 37, 6, 6, 8, 4, 3, 1. They've got 1 randomly at the top. State the number. Number, not probability. Exactly 1. So that's not 60 plus 55 plus 21. That's those individual sections there, isn't it? So that was kind of a clue to not put 60, 55, 21 as only. So 3 and 6. As well. 18. Proportion, another way of asking probability. Not F as my other 2. So not F. What proportion of the students who do not admire F? See, I think this is a given that. What proportion of the students who do not admire the other 2? I think it's a proportion question. I think it's a given that question. So instead of actually saying the word given, the information we've been given is that from the students who admire F, who do not admire F. So out of the F dashes, prefer the other 2. What's the chances they like the other 2 given they don't like F? That's how I'm interpreting it. Oh yeah, there it is. If you unfold it, you can see it there. N and A given F. So notice the word given that is missing. Well, because the way it was phrased, what proportion of those who do not admire F like the other 2? That's how it was phrased. It was a hidden given that. What proportion of those who do not admire F? So it was a sneaky hidden given. Right, so 9 plus 37 plus 6 plus 1, 10, 47, 53. So out of the 53, rather than the overall total, which we still don't actually bother to work out. What's the grand total? 74. Anyway. N and A. So out of these, oh, it's those 37, it's quite a large probability. What's that as a decimal? 698. Right, the reason why I left this kind of question until later on today rather than this morning is because we know these phrase. 2, exactly 2, out of a random sample of 3. and the criteria is only N. There is something subtly said of these students. The reason why I've said it's of these students is because if you're treating that proportion for the population, you would just use that probability over and over again. And that would allow you to do your later techniques. However, we don't have that. Because if three of these students are picked, is there going to total 74? 53, 53, 56, 62, 70, 74. So because it's of these students, and we're picking three of these students, there are going to be three different students. So the first one's going to be out to 74, then 73, then 72. Does that make sense? Because it's out to these students. So the first pick's out to 74, then the second pick's out to 73, then 72. Only N. Only N. So we look for that 9. That 9. Let's go with the situation. Let's try and explain the situation. Let's say yes, yes, no. If the first one is one of the 9, the second one is one of the 8. That makes sense, because there's one less person to pick. Which means it would then be 7. But it's a no. We don't want that person, because we only want 2 of the 3 to satisfy the criteria. So how does that leave? Doesn't matter which subtraction you do, 9 away from 74, 8 away from 73, or 72, 7 away from 72, you're going to get 65. The last person cannot satisfy that criteria of only N. So yes, yes, no yields this combination. Now if I was to put that into a calculator, that would not get me the full marks. Notice how it's worth 4 marks. And the reason why is that's only one combination. What if the first one says, yes, I only support N, but the second one doesn't? That would be a 9, 65, 8, out of 74, 73, 72. The same probability again. What if the first person says no, and then the second one too? So it'll be 65, 9, 8, again the same probabilities, but in a different order. There's 3 different ways. This type of probability question is referred to as combinatorics, or combinations. So that probability alone, 9 74ths times 8 73rds times 65 72s, will only get you 2 out of 4. Numerator is correct, 9, 8, 65. Denominator is correct, 74, 73, 72. Times by 3 gets you that 3rd mark. Why times by 3? Is because there's 3 positions where the person who doesn't fit the criteria of only N could pick. Two out of 3. We've got to think of all the different combinations where it's satisfied. The one that you always write out is probably yes, yes, no in this situation. Where else could that no be? The no could be on the second pick rather than the third. It could also be the first. And hence why there's 3 combinations. There are situations where you're going to times by 6. There's going to be situations where you times by 3. I've not come across anything different, but it's always been 3 or 6. The 6 is when it's 3 different things. For example, ABC. There are 6 different ways you can rearrange the letters ABC. ABC, ACB, BAC, BCA, CAB, taxi, and then of course CBA. But yeah, if that question arises, we'll deal with that. Into the calculator we go. Those of you currently on Teams can have the answer into the team chat in about 20 seconds time. Don't press enter just yet. Let's just see that you're actually participating. Okay, 3, 2, 1. Press enter now. Good lad, Ellis. Cheers, Sergio. Cheers, Emma. Lovely, all full of you. That's fantastic. Now notice how it is 4 decimal places, but because that's 0 after the decimal place, that doesn't actually count as a significant figure. Okay, so what we've done there is we've done the 2 sample material questions, we've done a 2-way table into a Venn diagram. Here we've been given a list, but we've got to be careful to dissect those overlaps out of the totals. Because the key phrase only N, only A, only F was missing, we had to assume they were totals. Quite a common Excel question, which we practiced on Thursday. Okay. I think we've got a chance to do at least one more. I do like this question. Does it have a statistical independence on it? It does have a statistical independence question. So we could actually do the Department of State question as opposed to this one here, which is pretty much a carbon copy. Asks about B1 and H being statistical independent. Let's just go in order. So Department of State, I'll probably just crop this off. This question threw a few students off because 2-way tables, usually where you put your totals, usually put your tables at your totals at the end and at the bottom. And what they've done here is they put the totals at the top and at the left. Ugh. Ugh. First question, what's the chance of S? S is directed to Department of State. So Department of State, so the probability of S is 8 to 3, 8 to 7, makes a grand total 12,308. It's real life data we're talking about here, people. Nasty, nasty numbers. What's that? So table L dash. Probability of L dash. 2 ways of generating the number. Right, so L, late response is here. Late response is here. So actually, extension to deadline and deadline met are both L dash. So either we subtract the L from the total, or we add the 2 possible combinations for L dash together. Overall, that's 10,749 plus 626. Or like I said, you could take away the 933 away from 12,308. you'll get exactly the same amount, 11,375. Three sig fig, 3 sig fig. So far, it's a genuine question. I'm happy with those first 3 marks. Construct a Venn diagram to show the frequency. It's a good thing they've highlighted that frequency. Not probabilities, frequencies. Students who drew probabilities were marked down. So let's see, can I still see the numbers? Yes, I can. There's S and there's L. Thankfully, it's just the 2 events. Start with the overlap. 7, 6, 2 in the center. The others for departments of state, you can either take the 762 away from 8,387, or you can add the other 2, the 7195 and the 430 together. Is that 7625? I believe. Seven, 6, 2 is in S and L. The remaining L, which is not S, is 171. Over the easy L dash. So that 171 goes there. What's left over? You can either add them together and take away from 12,308, or more likely, just add the S dash L dash together. Which I think is 3,750. I like that. If that's another 3 marks, that's not bad. We had to do some subtractions, some additions. We just interpreted the notation of S and L. Yes, the table's a bit backwards, but doable. Yeah, this is a genuine paper, a genuine question. I'm happy with that, those 6 marks so far. Find the probability of S given S dash. Sorry, given L dash. So out of the L dashes, this is probably where it's going to get tricky, right? So out of the L dashes, the ones we want are the S's. Find the probability of S out of the L dashes. What was L dash overall? Did we have L dash somewhere? I think this 11,375 was the grand total, wasn't it? So instead of out to 12,308, we're narrowing that focus. We have been given L dash is the case, so that numerator, that denominator changes to 11,375. Out of the 11,375, it's those 7,625. That sum came from 7195 plus 430, the ones we've highlighted in yellow. Smashed it. For another 2 marks, love that. Anything which rounds to, anything which falls between, I think it's 6, 7. If you check the mark scheme very carefully, it wants the decimal answer. And this was a question that was brought up this morning about do you have to give the decimals. Now, nowhere in the actual question does it say give your answer as a decimal, but if you look at the mark scheme, they're adamant on the decimal. I think that's quite fascinating. Part D. Are the events S and L dash statistically independent? Do you remember what we need to do for this one here? That's an open question to the room/team. What do we think? We're trying to prove or determine whether S and L dash are statistical independent. What's the definition of statistical independence? What would we do here? What do we think? Maybe look back at your notes from this morning.
A and B.
A and B. Is A times B. That's what we're hoping is true. That's the question we need to check. Is the probability of S and L dash, is that the same as timesing the two separate probabilities together? Because if it is, it will be in the correct proportions. Do we have the probability of S? Was that A part 1 by any chance? Do we have the probability of L dash? Was that A part 2 perhaps? It's clever this, isn't it? It's almost like they're helping us. So looking at A part 1 and A part 2, we've kind of got a partial answer already. Still a question, we don't know if it's true just yet. The answer to A part 1, the probability of S, was 8-3. I'm going to use the fraction so it's nice and exact. Given how nasty these numbers are, I think it's kind of higher than I thought. I don't spot any multiple anyway. Because you've got some numbers which are multiples of 3s and some which aren't. Actually, they're false numbers are multiples of 3. So we work out that multiplication, see what it equals as a decimal. S and L dash, S and L dash. Well, that would be the 7,625, not restricted to the L dashes. This is just the chance of S and L dash overall. Let's work that out. Is 7,625 divided by 12,318. I get 0.6195, which measures to 620 to 360. Is that the same? That's 8387. 65, so divided by 12,308. Oh, close. So you had 6195 for S and L dash. Then you had 62977 for S times by L dash. Oh, that's super close. Super close. I mean, they are likely to be independent, however, we haven't quite got the perfect statistical independence here. They're not quite the same. They have to be bang on the same proportions. Alright? So we summarise the events of S and the events of L dash are not statistically independent. I mean, it's close, and I feel a bit harsh for the proportions that we've produced, but no, they are not exactly statistically independent. Okay? That 2019 one you can do in your own time, and it doesn't quite come out as statistical independence for that one either, but same idea. Okay? That was only 40 minutes. Thank you very much for your attendance and your engagement. Don't forget, homework is numerical measures for this week. I will set the probability one for next week, and I'll look into what we'll do as an initial assessment ASAP. Thank you all. Cheers.